a problem with two chemical equations, so we're going to be using two mole-to-mole ratios. First, however, we have to balance both chemical equations. Remember, practice this on your own prior to the quiz. Alright, so now we have two balanced chemical equations. Next, we identify the chemical that's in common to both equations, and in this case, it's H2 gas. So we see H2 gas here and H2 gas here. Now we're asked to relate the amount of zinc to the amount of gaseous water. Relating one chemical to another, it has to be done on a mole-to-mole basis, and we're given amounts of water in terms of liters of gaseous water at STP, so we're going to use the conversion factor where 1 mole at STP is 22.414 liters. Now we find the equation that relates H2O to the chemical in common, H2. And we see that happens here. We pay attention to the coefficients associated with each of these chemicals. The next mole-mole ratio is going to relate amounts of H2 to zinc, because that's what we're interested in. The equation that relates zinc to H2 is the first equation. Here's zinc with its coefficient and H2 with its coefficient. So now we know the moles of zinc. We refer back to this statement of the question, and it wants pounds of zinc. So we can go from moles to grams to pounds using the atomic weight of zinc. So moles of zinc cancel out. We have grams of zinc. We go to our conversion sheet to find the conversion factor between grams and pounds. And here's the appropriate conversion factor. So we see grams cancel, and we have our calculator answer. And if we consider sig figs, we see we're limited by the number of sig figs in this initial measurement. So we have 2 sig figs justified in our final answer. And we have our final answer.